Welcome, everyone. Today, we are addressing one of the most significant challenges in modern industry, scaling predictive maintenance. While many organizations have successfully piloted vibration sensors or AI models on a handful of machines, moving that success to an enterprise scale across multiple plants remains elusive. This keynote is designed for leaders, directors, executives, and engineering heads who need to understand how to move beyond pilot purgatory and build a robust, data-driven health system for their entire asset base. From a board-level perspective, scale is where the value lives. A single successful pilot proves a concept, but enterprise scale proves a business system. Our goal isn't just to see alerts. It's to create a standardized environment where predictive insights from thousands of assets are converted into planned work. When we look at the enterprise overview, we want to see avoided downtime and OEE improvements measured in millions of dollars, supported by a clear answer to 5 key questions. Can it scale? Who owns it? What is the value? How is risk controlled? And how do we sustain it? So why do rollouts stall? In a pilot, you have high vendor attention, hand-cleaned data, and a local champion pushing every alert. But at enterprise scale, complexity explodes. You're dealing with mixed asset classes, from rotating equipment to complex electrical systems, scattered across sites with different cultures, varying data governance, and inconsistent maintenance maturities. What works in one plant often breaks when the underlying process and people aren't standardized. The evidence for why we must solve this now is clear. Data from NIST shows that moving away from reactive maintenance can reduce unplanned downtime by over 50% and defects by nearly 80%. Predictive maintenance is now identified as a core application for industrial AI. The strategic question has shifted from the technical, can we detect degradation, to the operational, can we convert thousands of signals into consistent financial value? To align our strategy, we must define what enterprise predictive maintenance actually is. It's a 4-step loop: detect, decide, act, and learn. If a prediction cannot be repeated across asset classes, translated into a clear work decision, governed across sites, and measured in business terms, it is still just a pilot capability. True enterprise maturity means the full loop is closed every time. The secret to scaling is knowing what to standardize and what to leave to the local experts. Think of it like a language. You must standardize the grammar at the enterprise level, things like asset taxonomy, data architecture, and KPI definitions. However, you must allow sites to adapt the sentence, the specific operating context, local maintenance windows, and site-specific failure modes. If you try to standardize everything, you'll face resistance. If you standardize nothing, you'll face chaos. This is our enterprise operating model. It's a layered approach where technology, process, and people intersect. At the base, we have the asset hierarchy and data capture. In the middle, the analytics and alert triage. But notice the top. Everything must feed into planning, execution, and strategy optimization. Without change management and clear ownership at every layer, the technology is just a cost center, not a value driver. Maturity isn't just about the tools you use, it's about how you use them. Many plants stay at level 3, using condition-based thresholds with local specialists. To reach level 5, or prescriptive maintenance, the data, work processes, and governance must mature together. A plant can have the most advanced AI in the world, but if those alerts don't change daily maintenance decisions, the plant is still operationally immature. When momentum is lost, we usually find one of these 10 root causes. Often, it's not the algorithm that fails, it's the system. Whether it's inconsistent criticality standards, alert overload, or a weak link to the CMMS, these gaps prevent the program from becoming part of the company's business as usual. We need to address these structural issues to ensure long-term success. We can cluster these failures into 4 domains: data, work, operating model, and change. Usually, scaling fails at the interfaces between these domains. For example, an insight arrives, data, but the planning process, work, doesn't know how to handle it because nobody owns the end-to-end outcome, operating model. Solving for scale means bridging these gaps, not just buying a faster server. The foundation for repeatability is simple: standardize before you scale. By establishing a common asset taxonomy, a shared criticality framework, and a unified KPI dictionary, you deliver faster deployment and lower costs. Most importantly, you build trust. When an alert means the same thing in Plant A as it does in Plant B, the organization can act with confidence. It all starts with an asset hierarchy that everyone can use. If the same pump is named 5 different ways across your systems, or if sensor tags can't map to CMMS records, your models will require site-specific rework every time. A stable enterprise asset ID and clear metadata fields are the master data requirements for any scalable program. We cannot put sensors on everything. Economics won't allow it. Criticality acts as our economic filter. We deploy predictive capabilities first where the consequence of failure is high, where the condition is detectable, and where a meaningful maintenance action exists. This ensures we are investing our resources where they will protect the most value. Similarly, we need a standard sensing strategy by asset class, not by vendor, whether it's vibration for rotating equipment or thermal imaging for electrical systems. The enterprise should define the minimum requirements for coverage, sampling, and metadata. This prevents a fragmented landscape of one-off vendor solutions. We've all heard garbage in, garbage out. At scale, bad data multiplies. A single defect in data quality, like clock drift or missing context, can trigger false positives across hundreds of assets, destroying user trust. We must implement minimum data quality controls, from time synchronization to sensor health monitoring, to ensure our insights are actionable. Our technical architecture must be built for the entire life cycle, not just initial connectivity. This reference architecture shows a seamless flow from the sensor to the CMMS. By using a dedicated integration layer and cross-cutting controls like model registries and audit trails, we ensure the system is secure, interoperable, and ready for future upgrades. As we scale, we must not expand the OT attack surface. Cybersecurity is a board-level concern. The design must be read-only by default from control networks, with strong identity governance and clear incident response playbooks. We have to ask, who can change a model threshold? Where does our data go? If a component is compromised, how fast can we isolate it? To prevent alert fatigue, we need a single, enterprise-wide alert taxonomy. We categorize alerts from advisory to critical based on the consequence, the lead time, and our confidence in the signal. Severity shouldn't be defined by a vendor's alarm color. It must be defined by the actual business risk. Models themselves require governance, much like the physical equipment they monitor. From the initial use case approval to monitoring for concept drift and eventual retirement, every model needs a clear owner and a documented lineage. This ensures that the analytics remain accurate and relevant as operating conditions change. Now we reach the most critical part of the presentation: closing the value loop. Value is won or lost in the transition from an alert to an action. This requires a coordinated dance between operations, reliability, maintenance, and finance. AI detects the anomaly, but humans must validate it, assess the risk, and ensure it gets into the weekly maintenance schedule. To make this work, we need absolute role clarity. Who does what after an alert? Operations validates the context. Reliability confirms the diagnosis. The planner secures the parts, and maintenance executes the work. The process cannot depend on a heroic analyst who happens to know who to call. It must be a documented, repeatable workflow. The CMMS or EM integration is where predictive value becomes real work. A bad integration pattern, like sending a manual email, means finding are never coded and the model never learns. A good pattern automates the work request with the right evidence, ensuring the job is planned, scheduled, and documented for future audit. Planning and scheduling are the engines of maintenance. For these engines to work, the planner needs specific details from the alert. What is the defect? What parts are needed? How much time do we have? In return, the predictive program needs feedback. Was the defect there? Was the repair successful? This feedback loop is what makes the system smarter over time. We must be aware of the value funnel. Out of 1,000 raw anomalies, we might only find 72 verified value cases. This isn't a failure. It's a necessary filtering process. Scaling requires aggressive triage and risk-based prioritization so that our maintenance teams are only working on the issues that truly matter. Trust is the currency of adoption, and it's earned one work order at a time. We move from low trust, where the system is seen as crying wolf, to integrated practice, where predictive alerts are simply how we run maintenance. Adoption isn't a one-time training event. It's a culture built on consistently relevant and actionable data. Our organization should follow a federated model. An enterprise center of excellence defines the standards, architecture, and governance, while the individual sites own the execution and the results. This balance ensures consistency across the fleet while empowering local teams to manage their specific assets. Decision rights must be explicit, as shown in this RACI chart. For example, while the enterprise lead is accountable for standards, the site reliability lead is responsible for alert triage. Knowing who is responsible versus accountable prevents bottlenecks and ensures the program moves forward without constant executive intervention. It's important to remember that not every plant is ready to scale at the same time. We segment sites by maturity. Plant A might be ready for full integration, while Plant C needs to stabilize its basic work management first. Sequence your rollout by readiness and value. Don't just force a tool onto a site that isn't prepared to use it. There are different scaling strategies. You can go by asset class, by plant, or by failure mode. Often, a hybrid portfolio is best, focusing on critical assets at ready sites. This balances the speed of deployment with the need for high value, provided you have the governance in place to manage the complexity. As we move into the financials, please note that the following values are illustrative. You should replace these with your own company-validated economics before presenting to your board. The business case should be built from measurable value drivers, not just theoretical savings. We look at avoided downtime, avoided secondary damage, labor efficiency, and inventory optimization. A key rule: do not count a predicted failure as value until you can validate a specific avoided consequence or a better decision outcome. This value tree shows how a technical finding, like bearing degradation, flows into the language of the board: capacity protected, cash preserved, and risk reduced. By connecting the technical to the financial, you make the program's success visible to stakeholders who may not understand vibration analysis, but certainly understand throughput. When calculating costs, look beyond the sensors. Scaling entails platform licenses, integration work, and, most importantly, people and change management. Many pilots are subsidized by vendor favors or manual data cleaning. When you scale, those hidden costs will appear, so it's vital to budget for the full life cycle from the start. Investment should be stage-gated. We don't fund the entire enterprise rollout at once. Instead, we tie funding to evidence. Can we detect the condition? Can we change a decision? Is the value greater than the cost? This approach reduces risk for the board and ensures the program remains focused on performance. We prioritize our portfolio by value and repeatability. High value, high repeatability assets, like critical motor trains or common gearbox fleets, are the first candidates for scaling. Low value or unique one-off assets are either handled by specialists or not industrialized at all to avoid wasting resources. In this illustrative multi-site scenario, you can see how a standardized program creates a net annual value across the enterprise. Here, we see a gross value of over $10 million with a 2.8x value to cost multiple. Tracking these numbers at a site level allows you to identify where the program is thriving and where it needs support. We need a hierarchy of KPIs. While the board cares about EBITDA and risk, the reliability team cares about asset health, and the analysts care about precision and recall. Never use analytics accuracy as your only measure of success. A perfect model that doesn't trigger a work order is useless to the business. The executive scorecard should be simple. The board needs to see 5 things: the validated value, the risk exposure, critical asset uptime, adoption rates, and the progress of the scale-up. A narrative like 89% of high-priority alerts converted to planned work tells a compelling story of operational discipline. Leading indicators tell us if our scale is sustainable. Are our sensors healthy? Are alerts being converted to work requests? Lagging indicators, like unplanned downtime and capital avoidance, tell us if the strategy worked. By monitoring both, we can fix problems in the workflow before they show up as failures on the plant floor. This is a 24-month roadmap. Scale is a transformation program, not a software rollout. We start by proving the value, then we build the foundation of standards, industrialize the workflow, and finally institutionalize the capability. Each phase is supported by governance, cybersecurity, and change management. In the first 6 months, our objective is to prove the value model. We choose high-value use cases and define what success looks like. The exit criteria for this phase are clear. The signals must detect degradation, and those alerts must change a real maintenance decision. The middle 6 months are focused on the foundation. This phase can feel slower because you aren't adding many new sensors. You're setting the rules for taxonomy, criticality, and data quality. But this is where rollout speed is created. Without these standards, every new plant is a painful integration project. With them, it's just configuration. In phase 3, we industrialize the workflow. We ensure the CMMS integration is seamless and that site roles are clearly defined. Industrialization means the system survives even if a key champion leaves or a vendor changes. It becomes part of the fabric of how the company operates. Finally, in months 18 to 24, we reach full scale. We roll validated economics into annual budgets and use fleet-level feedback to improve our maintenance strategies. The end state isn't just having assets monitored. It's having a repeatable, risk-based decision system that drives results across the globe. Every enterprise program faces risks, from technology sprawl to site resistance. Our countermeasures must be proactive, using reference architectures to prevent sprawl, common taxonomies to prevent alert overload, and clear financial validation to prove value. Addressing these risks early prevents the program from losing steam. As we conclude, I've listed 12 questions every board or executive committee should ask. These range from who owns the end-to-end outcome to what evidence triggers the next funding tranche. Using these questions will ensure your program stays focused on risk reduction and financial reality. To close, leadership must set a clear enterprise owner and standardize workflows before trying to scale. Remember that a pilot proves the technology, but scale proves your operating model. Alerts only matter when they drive disciplined action. Thank you for your time, and let's move towards scaling predictive maintenance as a true enterprise capability. On this final slide, we have provided the public references and industry standards that inform this presentation, including data from SMRP and NIST. This deck is intended for educational and professional discussion. Please ensure you verify all company-specific facts and cybersecurity requirements as you begin your own scaling journey.